All right, here we go with completing the square. So this is a square. Yes. Its dimensions are x by x. Now, this is also a square. Its dimensions are 1 by 1. And then I'm going to introduce these friends whose dimensions are each 1 by x. So, right now this is a perfect square. It is complete. What if you had an extra x on this side and also on this side, thus making it so that it is not a perfect square? Well, those terms would be x squared plus 2x. So what do I need to add, pray tell, to this little tiny corner that would thus complete, that would thus complete the square? Why, yes, you would need to add one of the little blocks. 1. Now, look at the new dimensions, the width and the length of the square. It is now x plus 1 by x plus 1. So you would say that that is x plus 1, the quantity squared. Let's try another one. So, what if there was an extra 2 x's on each side? And forget about this little guy. Look at this big empty gap. Empty hole. Gaping hole. What would we need to complete the square? Well, I'll go ahead and I'll put this 1 back in there. Ugh, alright, I don't like that one. Whoops. Let's grab another 1. And another 1. And how many did it take for us to complete this square? Yes, you are right, it took 4. Now look at the new dimensions of this square. X plus 2 on the width and x plus 2 on the length. How about that? X plus 2, the quantity squared. Well, let's see if your wild guessing is working today. What number could be used to complete a square if it had 3 units added on to each side? And remember, you can pause the video at any point. So think about it. 3x on each side, total of 6x. What would be used to complete that square? Well, remember those dimensions now would be x plus 3, the quantity squared. So the new area that needed to be filled would be 3 by 3, which would be 9. So, a couple of patterns here to notice. Do you notice this column of numbers seems to be perfect squares? Well, that's good because we're completing some squares, right? How are those numbers related to these numbers? Well, when there were 2 x's, there was 1 added on each side for a total of 2, and that made 1 by 1 the missing part. when there were 4 x's, that made 2 on each side, making the missing part 2 by 2, or 4. If there are 6 missing, it means there are 3 on each side. 3 squared is 9. So what am I doing each time? I am cutting in half the number of x's and then squaring it to complete the square. So half of 4 is 2, 2 squared is 4. Half of 6 is 3, 3 squared is 9. Now you should notice this number is what always appears in here, because those are always the dimensions, the growing dimensions of my square. So let's try it here. So half of -8 is -4. Square that, and we should get 16. And what would that make for the binomial squared? Well, it should match, and we should get x minus 4. If you don't believe me, let's do some FOIL. X minus 4 times x minus 4. Okay, first, outer, inner, last. Do you see that as x squared minus 8x plus 16? Yes! Alright, very nice.